So now we will do propagation of sound wave in a medium. See, we have done two types of wave motion like longitudinal wave motion and transverse wave motion. In longitudinal wave motion, we have done particles of the medium vibrate in the direction of propagation of the wave. Sound is an example of the longitudinal wave. So now we will see here how does sound travel in a medium. See here, this is here a speaker. As sound comes, there is a variation in the density of the medium. So see here, first I have taken here in this portion where the particle comes very close to each other. There is a high pressure. This high pressure means higher density here of the medium, and these are known as C, that is compressions, and here we have taken C as a compressions. In next, particles of the medium gets rarefied, there is a less pressure, so this is called rarefaction. Already it is mentioned in the diagram R, and this R means this is a rarefactions. So when sound travels in a medium, compressions and rarefactions are formed. Just after compressions there is a rarefaction, then again compression, then again rarefactions. So here this will be the compression, this will be the rarefaction, and this will be the compression. By this way sound will keep on traveling. So there is a variation in the pressure, or you can say there is a variation in the density with the time. So now we can represent it by a graph also. So if you take graph in this way here, here I have taken higher density, so we can start like this, in this way. This side I am writing here density, this is a time. So there is variation in the density with the time, this is representing this C where maximum density is there. As we go ahead, density reduces, and at R the density is minimum. So these points where density is minimum are called, we can say these are called trough, and where the density is maximum, this and this point, we can take, these are called crest. This line represent average density. So now see here, the distance between two consecutive crests or two consecutive troughs is known as wavelength. So we write here the wavelength. So wavelength is represented by lambda. It is the simply distance between two consecutive crests or troughs. We represent it by lambda. Unit of wavelength is meter, that is m. So unit of wavelength is meter. So now we have represented variation of the density with this graph. We have defined wavelength. We have defined wavelength between two consecutive crests as well as two consecutive trough. But if you see the distance between one crest and adjacent trough, that will be lambda by 2, half of the wavelength. So if you start from here, this is the 0 we can take, and here if you start from here, the wave will be completed here. So we can take here, this is t. So the distance, the time taken by the wave from here to here to travel, or from here to here, or from here to here, or this is known as time period. So the time taken to complete one wave is the time period. Time period is represented by here t, that is t is called time period. Suppose if you are starting wave from trough, so the next trough I find just time to from one trough to another trough, how much wave has taken to go, that is called time period. Then there is another terminology comes, that is called frequency. Frequency is actually number of waves in 1 second. Frequency is represented by nu is equal to 1 upon t. We represent time period in seconds and frequency is actually 1 upon time period, reciprocal of the time period, its unit is, so unit of frequency is hertz represented by Hz. So, these are the different terminology related to the wave. So, we have seen how does sound wave travel in a medium. Now, we have defined wavelength, time period, frequency. One more quantity is here. This is the mean position we have taken. This line where we have taken average density. This is the maximum disturbance from the mean position, this side with this side. These maximum disturbances from the either side of the mean position, whether you take this side or this side. So, these maximum disturbances, or you can say maximum displacement from the mean position, is known as amplitude. So, there is one more terminology here related to, we can write here amplitude. So, amplitude is just a displacement, we can represent by a unit is meter, because it is just a displacement. Whenever we take displacement, unit is only meter. So, this is the sound wave and different terminology related to this. Now, we will see another characteristics of the wave, like a pitch, quality as well as loudness. So, what do you mean by pitch? So, pitch means you might have observed different frequencies. If we take a pitch, suppose there are 2-3 musical instruments are played together at a time. Both are sound produced by these musical instruments travel with the same speed in air, and both sound waves are reaching to you, but still you are able to recognize which sound is of the which instrument. This is due to difference in frequencies. So, there are some more characteristics of the wave, like we can take pitch. What do you mean by the pitch? Basically, the pitch is representing frequencies. Suppose you have taken 2-3 musical instruments and both are played together, and somebody is hearing these sounds. Now, what happens? If all these sounds are traveling through air, they are reaching at the same time to the observer, but the observer can easily differentiate between the sounds of the different instruments. Why? Because of the frequencies produced by the different instruments. So, different instruments produces the waves of the different frequencies. So, pitch represents frequency. If the frequency is higher, we can say pitch is higher. If the frequency is low, we can say pitch is low.